Okay. Hi, everyone. Welcome. Thank you all for coming. Hi, my name is Alyssa Tomlinson, and thank you for coming to my thesis presentation on teaching students to develop mathematical arguments. So, in short, of my 4 years of teaching so far, I've not only learned a lot about my students, but I've also noticed a lot of common trends. For instance, students only write the solutions, but they never take time to explain their steps or how they got their answer. I've learned that only 5 to 10% of my students can write a mathematical argument. And I'll explain briefly in a little bit what a mathematical argument is. And I've also learned that my students need a lot of prompting and tools to get started. So taking these ideas and concepts for inspiration, I started thinking about how can I better support my students. And in order to really learn about those things, I started doing a literature review. And these were two of the main sources that I used. And as well as several other sources. But what I learned was that teachers are consumed a lot by the literacy components of word problems and by the steps of even more complex problems. So when teachers are teaching word problems, sometimes they're focused on like the vocab words and things like that, or like teaching students step by step, and not so much teaching them the skills and the tools they need to solve those word problems on their own. Additionally, as educators, we are seeking a much higher demand in critical thinking and communication skills, and a lot of that has to contributes to the 21st century. And I've also learned through my research that when students reach Algebra 1 or even higher level mathematics courses, they have little foundational or basic skills to solve word problems and things like that. A lot of times they're just learning the steps of how to solve specific problems, but they're not really gaining the skills as mathematicians to solve problems on their own or independently. So this brings me to my research question. How does the three-read protocol promote mathematical argumentation in writing during distance learning? So I'll get into in a little bit exactly what the three-read protocol is. Some of you as teachers might be already familiar with it. But my whole, or most of my study really is on promoting mathematical argumentation in writing in the math classroom, which I think is something that I've noticed is missing in our math classes today. And it's something I didn't really get taught until I was in higher level math courses way later in my high school career and then in my college career. So just a little bit of background information about the school and where I teach. The students that I surveyed are in high school geometry, they're 10th graders. We've been 100% online since March of 2020, where I'm teaching courses through Zoom, and students are learning material that way. In our school, there's approximately 829 students. 23% of those students are English learners. 88% of those students identify as Latino or Latina, and 96% of those students are economically disadvantaged, meaning that their parents did not graduate high school or they qualify for free or reduced lunch, sometimes even both. So when I started doing my research, I started in phase 1. I just conducted a survey through Google using multiple choice or Likert questions. And Likert questions are the types of questions that are on a scale from 1 to 5, where 5 is strongly agree, and then 1 would be strongly disagree. And then after this, in addition to the survey, also gave students a pre-assessment that told me where they were in terms of writing a mathematical argument. So to kind of go over what I found in the survey, so I'm just going to highlight a couple things from the survey. So one of the questions I asked the students or to rate themselves is you feel confident in your ability to write sound mathematical arguments in complete sentences. So meaning that if you could, as you can see here, we have that like nice bell-shaped curve where most of our students don't strongly agree with that statement, but they don't strongly disagree with it either. They're kind of in the middle. And then I also asked them if they enjoyed solving word problems. Even though a majority of students are in the disagree, I also have, are in the strongly agree side. I also have a significant amount that strongly disagree and that don't really enjoy solving word problems. And then the third part of the survey I also kind of highlighted to myself was discussing different solutions is a good way of learning math. And most students agreed with that statement. I still had a few over here that did not agree, which I found kind of interesting. And it'd be something I would like to have looked more into, but due to time, I just could not. So with the pre-assessment, what I did was I challenged the student by giving them a complex problem. Now, even though there's not a lot of words in this problem, there's a lot of syntax and context clues students would have need to have derived from in order to solve the problem. So with this assessment, I used a challenging question that was relevant to the material that we had just learned. And when I was going through and reading their responses to this mathematical argument, I was looking to see if they not only had the solution, but if they were able to justify their arguments in complete sentences and things like that using some sort of mathematical evidence or reasoning. So of the 17 students who responded to the pre-assessment, I ended up going through their papers and I gave them specific comment codes. As you can see, a majority of my students got the correct answer, but were not able to justify their reasoning. I also had significant amount of students who made an attempt at the problem, but their answer wasn't correct. But they also, a lot of them did try to make an attempt to justify their reasoning, but they just did not seem to understand how. And so let me show you a few student examples. Student A, as you can see here, wrote a very brief answer, but that student put, I would assume that's the answer. That's not really a justifiable or strong mathematical argument. And then I have student B who wrote a lot of information, but when you really broke down what what they wrote, you could see that they were guessing, they were not really sure, and that they were just trying to throw it up there as much as possible, but they were not really sure on what their answer was or what their argument was. And these were common trends that I saw throughout while I was grading their pre-assessments. So my research timeline. So now that I collected all this data, had all this information, I went ahead and I started implementing the 3-read protocol. And I challenged the students to revise their pre-assessment submissions. So why did I choose the 3-read protocol? I chose it because students need to begin not only verbalizing their thoughts, but they need to move towards understand more mathematical ways of communicating their ideas. So in other words, when students really understand and grasp a problem, they're able to write about it. So I wanted to make sure that students were not only able to read through these complex problems, um, but that they had the skills to do it long term, and so that they could become stronger writers when it comes to writing about math. So I went ahead and I implemented the intervention. Because we're online and distance learning, I couldn't use observational data because a lot of my students had their cameras off and whatnot. But I went ahead and I used the Nearpod participation tool to kind of collect data as I was presenting the problem and going through it with students. Um, with the 3-read protocol, and that's the slide that you see on the screen there. I gave them kind of a lengthy word problem, but we worked through it together in 3 steps. So more specifically, what is the 3-read protocol? We're basically reading the problem 3 times. So the first time we read it, and then I asked them what the problem was about. Students mentioned that it was about changing the scale, making and changing sizes and expanding shapes, using transformations, all things that were relevant. And then we went back through and we read it a second time. And I asked them, so what am I trying to find out? And one student mentioned, how can I get the artist to find a way to make the shapes grow as many times possible without the shapes losing the look? So now we're on to something, right? And at that time, I was introducing the concept of dilation, which is where you take a shape and you multiply it so that way you can have, for example, like a small, a medium, and a large. Okay, and then I challenged them again for the third time, and I asked them, what is the important information in this problem? So with that, I had some students say, well, they can change the size of the shape so it's twice as big, and then a few students started to mention, well, we need to multiply all the coordinates. So as soon as I got a few of the students to say that, I'm like, well, you guys already know what the answer is. You just read it and figured it out. So students then kind of, it was a light bulb for many of them, and like, oh, I know how to solve this problem. So with that, after we completed those activities, I went back and I'm like, okay, let's go back and revise that other problem. And even though the 2 problems were not related in terms of content, it was material that was fresh for them. So with those same 17 students, I had a significant amount of students increase in terms of their um, ability to not only write the correct solution, but justify their reasoning. And sorry. So just to show you guys a few student samples. So student A, that was her answer before, and then that was her that was her answer the second time around. As you can see, she really starts to break down step by step what she's doing in order to get that answer. It's not a full justifiable argument yet, but you can see it's a huge improvement compared to where we were at the beginning. And for my student B, she also greatly improved her argument as well. You can see that the student started using vocabulary words and things like that because they had a much better understanding of the problem. And when I went back and had them revise the problem, I did go over it with them, and we discussed the solution together as a class. And then in addition to that, I also provided them a video of me going through it step by step, so that way they could come back and work on this and write their own summary of the problem and how to solve it. So this brought me to the third and final part of my research, where I gave students a post-survey and another post-assessment. With the pre and post surveys, I didn't have the same sample size, so I couldn't combine the graphs, but for the most part, the trends are for these questions pretty much remain the same. I didn't have a significant amount of students show like an increase or decrease in confidence in terms of writing a mathematical argument. Nor did I see a drastic change in terms of students who enjoy solving word problems. And And then for the third question, a lot of students still believe that discussing different solutions is a good way of learning math. So when I did the post survey, I did add a question and I asked if students felt that writing in mathematics, if their writing in mathematics class had improved this semester. And as in the 49 responses that I got, a majority of the students leaned towards the strongly agree side. Um, and I could see a lot of that in their work too. I saw a lot more effort and students being more thoughtful in their answers in terms of what of the work that they were producing in this. And I could see that um, just moving on in future lessons that they were thinking a lot more about the problems and reading the problems a lot more carefully. So just to quickly summarize my findings, the three-read protocol did provide students with a tool to use strategically when solving word problems. And when students are able to read and understand a complex problem, they're more able to write about it. Students were in, I'm sorry. But yes, students are able to write more confidently when they understand that problem. And that revision allows students to think deeper about the problem. So actually going back and challenging students to go back and revise their work in math makes them think a lot more deeply about math problems and they build a better understanding of it. Um, that's a common practice in English to go back and revise essays, but now I think it's something we need to start doing in math classes as well. And I also found that a majority of my students' writing did improve all over time as I was implementing these things. So my next steps as a teacher, I plan to continue finding and embedding problems and writing opportunities for my students. I plan to continue implementing strategies like the three-read protocol so that students are able to solve those complex problems. And I'm going to also continue just providing those challenging problems for students to respond to. These are just some thoughts from my students when I asked them to reflect on their pre and post assessments. As you can see, a lot of them, um, learned how to write mathematical arguments, and they started to really understand the importance of doing so, and really being able to learn how to use their previous knowledge and understand their mistakes. These are just some of my references, but thank you for attending, and I will now do Q&A.